Alright everybody, so this whole nuclear thing is based on, hopefully you got the check-in right, in nuclear reactions we can do nuclear power from that because energy is released when an atom undergoes fission or two atoms undergo fusion, because some of their mass each time is converted directly into energy. So that means that, oh man, excuse me. That means that if you add up the mass of this, in fusion, when things are going like this, if you add up the mass of this atom and this atom, it's going to be more than their sum when they hit. And it's not just that it loses, like some particles go flying off. Like if you take all those particles that do fly off and add those to this new atom, it's still less than this and this. So that mass got converted directly into energy, and that's why it's so efficient at heating up stuff. Like it said in that Bill Nye video, you don't need very much matter to run a nuclear reactor plant, and it doesn't produce that much waste, but the waste it does produce is quite problematic. And it's the same with fission. So if you take this atom that is undergoing fission and you add up this atom, and then to make it do fission you have to bombard it with neutrons. So add up the mass of the neutrons you're shooting at it, plus this, when it splits, and it releases some particles. If you add up this half and then the mass of the particles it shot off there, that's still less than the total mass before, and that mass got converted directly into energy. And of course, like I said on that other thing, the only thing that we use for power plants right now is fission, when something splits in half. Really? So we can calculate that, and I just have 6 questions here for you. I'll even do one for you. So, this guy, there is a document where I wrote on the board that's attached on here that puts these numbers in scientific notation for you, so you don't have to go down here and figure out what is 3.23 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm pretty sure it just says that, right? Yeah, I did it. So this one, we've got, I'm not going to write right.
Are you going to be posting the answers?
Maybe. I've got, what do I got? If we converted this kitty litter into energy, if only we could do that. If only, that would be nice. But, so that mass of the kitty litter is 7.01 times 10 to the negative 4 kilograms. And it's that many joules of energy. That's a lot. What is that? 6.31 times 10 to the 13 joules. And so he's trying to figure out the speed of light. If he did this, if he did it right, he should get the speed of light that he knows. So we're going to find out the speed of light. So all of this, we can calculate that with this formula, E equals mc². Did y'all figure out that that's where we're going? This is called mass energy equivalence. That mass, when that fission happens, the mass that's lost, if you take that mass and the energy it did, the mass is proportional to the energy that's lost by a factor of the speed of light squared. It's pretty cool. It's pretty cool. And you notice this looks like, this kind of looks like 1/2 mv², where c is the speed of light, so it's even kind of like v. There's just not a 1/2. The reason for that is that this is not like this kitty litter, when we convert it into energy, or like when we do the fission with those the fissionable material, we don't have to make it move in order to get energy out of it. So it's not kinetic energy. It doesn't need the 1/2. It's called rest energy, and there's some complicated math and stuff that goes with it that gets rid of that 1/2. But that's why it looks like that, because it is. It's energy. Anyway, we can figure it out. The mass is that 70.01 times 10 to the negative 14. No, 10 to the negative 4. Negative 4. Kilograms and, oh dang. The energy is that 6.31 times 10 to the 13 joules. And I'm trying to find c², so if I divide both sides, oh man, I can't write. Cancel. And if I do that, what do I get for C? 9 times 10 to the 16 for c², and that should kind of tip us off. And that's technically meters squared per second squared. If we take what joules is and divide it by the kilograms there, you end up with meters squared per second squared, since joules is made of those kilograms and meters and seconds. That's c², so square root of c² is c, and square root of 9 times 10 to the 16 is 3 times 10 to the 8 meters per second. So yes, scientists did it right. I did this example because there's one other one toward the end of the questions that asks you, what is this a scientist in a different universe does this calculation? What's the speed of light in that scientist's universe? First of all, if the speed of light is different in his universe, everything is probably different, and E equals mc² probably would not apply. The mass energy equivalence would not be the same proportions and all that. Maybe it wouldn't even work. And that would take a lot of imagination to figure out. But let's pretend that the only thing that's different is the speed of light, and you're finding the speed of light in that other question. So you use the same process that I did. Any questions? I'm sorry, I have so much clearing throat to do. Once you finish these 6 math questions here, there's a nuclear quiz that asks you about fission and fusion and stuff. If you want to look back over that nuclear weapons thing that we did, you can, and that would help you do the quiz. Or I don't mind if you look that up either, if you've forgotten. But it's just to help you keep reminding you about this nuclear stuff. So do that after you do equals mc².